Hi, we're going to do section 11.3 today, the volume of a pyramid or a cone. Usually we do an investigation for you to get to the conjecture. Today I'm going to start with the conjecture, and then I'm going to show you where that conjecture came from. If this were a normal year, you would actually be doing an activity instead of me taking pictures of an activity that somebody else did online. So here's conjecture number 93. The volume of a pyramid or a cone, those are both solids that come up to a peak, is 1/3 times the area of the base, B, multiplied by the height of the object, capital H, or volume equals 1/3 BH. So I have a picture of a pyramid on the left and a cone on the right. And above it says the volume is equal to 1/3 times the area of the base times the height of the object. So let me get to the slideshow now here. Okay. So this pyramid and this prism have the same height and congruent bases. On the next slide, you will see 3 of these pyramids and this one prism. Okay, so there's our prism sitting there, and there's our first pyramid, and they're going to fill it with the green liquid. Second step, they're going to pour that into the prism. And see how it does not fill the prism. You can see in this picture how much it was filled already from the last pour, and now they're filling a second pyramid. They're pouring that second pyramid into the prism. It does not fill the pyramid totally. So here's the empty one that they used before, sitting next to it there, and then they're pouring in their second one. Okay, then they fill the third pyramid. Green liquid again. You can see the other 2 pyramids sitting there. They've been used already, and they're just sitting there now. And then they pour that into the prism, and finally, after they've used 3 of these pyramids filled with the liquid, it finally fills the prism. So 3 pyramids equaled 1 prism, or if I take 1/3 of each side, 1/3 of the pyramid would become a 1, and 1/3 of 1 would become the 1/3. So 1 pyramid is equal to 1/3 of a prism. So the volume of a pyramid is 1/3 times the volume of a prism. So the volume of a pyramid is 1/3 capital B times capital H, because the volume of a prism is area of the base times the height of the object, and I'm just putting a 1/3 in front of it. Okay, this cone and this cylinder have the same height and congruent bases. On the next slide, you will see that it takes 3 of these cones to fill the 1 prism. So they fill the 1 cone, they pour it into the cylinder, fill a second cone. You can see already that it's 1/3 has been filled there, kind of. Fill the second cone, dump it in. Now we have about 2/3 of the cylinder filled. And then they take the third cone and fill it with a liquid. And finally pour that in. So now finally, after 3 of those cones have been filled and poured into the cylinder is now full. So 3 cones equaled 1 cylinder. Or if I take 1/3 of each side, 1/3 of this and 1/3 of this, 1/3 of 3 is 1, and 1/3 of 1 is 1/3. So 1 cone is 1/3 of a cylinder. So the volume of a cone is 1/3 the volume of a cylinder, and since the volume of a cylinder is base times height, area of the base times the height of the object, then the volume of the cone is 1/3 area of the base times the height of the object. So just to review, here it is again. Here's your conjecture number 93. The volume of a pyramid or a cone is 1/3 times the area of the base multiplied by the height of the object. And you can see here, I have found a picture of a pyramid with the same base and height as this cube, and they're showing you in this picture that when they put it in there, it only filled 1/3 of the cube. So the pyramid is 1/3 of the area, or the volume of the prism, which is the cube. And then I kind of fudged this one, so I found a picture of a cone and a cylinder, and I tried to get the same drawing here. So when I pour this in here, it only gets filled 1/3 of the way. So the cone, the volume of the cone, is equal to 1/3 times the volume of a cylinder, which is area of the base times the height of the object. Okay, now there are two examples that they give you in the book. A cone has a base radius of 3 and a volume of 24 pi cubic inches. Find the height. So it says start with the volume formula and solve for h. Find the height, solve for h, and they tell me the volume, so I use the volume formula. So here's the volume formula. Volume equals 1/3 area of the base times the height of the object. Because this is a cone, the area of the base, well, that's a circle, so it'll be pi r squared. So now I have taken this formula and revised it so it's more accurate by putting the base as pi r squared. Now, what do I know? The volume is 24 pi, so this gets replaced with 24 pi. The 1/3 stays 1/3, the pi stays pi. The radius they told me over here is 3, and I have to find the height. So now what did they do? They left the 24 pi. They made this be a 9. 9 times 1/3 would be the 3, so there's 3 pi times h. And then to get the h alone, divide by 3 pi on this side, divide by 3 pi on this side. The pi's cancel out. I get 8. The 3 pi and the 3 pi cancel out, and I get an h. So the height of the cone is 8 inches. And here's the last one. This is a humdinger because it has some stuff over here which is kind of hard. Goes back to stuff we've already done. So the volume of a regular hexagonal pyramid, so I have to find the volume of a regular hexagonal, so hexagon, so it has 6 sides, all the sides are equal because it's regular. It's a pyramid, all comes up to a point up on the top with a height of 8, so that's what they're showing me here. Each side of its base is 6 centimeters. So this is 6 and this is 6, etc., all the way around. So they say, okay, let's start working with this. They're going to find the area of that base first. So they say that that base is a regular hexagon. So remember the regular hexagon? The area of a regular hexagon, a regular polygon, is equal to 1/2 SAN or 1/2 AP. Remember that? So S is the length of a side, A is that apothem, and N is the number of sides. If I take the length of a side and the number of sides and multiply them together, they actually become the perimeter. So that's the formula they're using, 1/2 AP. So here's their base formula. Okay, so now what do they have? The base is equal to 1/2. Okay, where's this apothem coming from? Okay, down here, here's my hexagon. They like to use hexagons because in the hexagon, I can make 6 triangles, which means that each of these angles, 360 divided by 6, would be 60 degrees. But then I split this one in half, so that's 30 and 30. This is 90, which means this is 60. So I have a 30, 60, 90 degree triangle. The side across from the 30 is A. The hypotenuse is 2A. And the side across from the 60 is A square root of 3. Okay, so now what do I know? A side is 6. So this side is also 6, but when this comes down, that altitude, it splits it in half, so this is 3 and 3. So that means A is 3. So this piece here is 3, A is 3, which means the apothem, this is this guy right here, is A square root of 3, ta-da, 3 square root of 3. So that's where that 3 square root of 3 comes from. And then the perimeter I have 6 sides, and each of the sides has a length of 6 centimeters. So when I multiply those, that's where the 36 comes from. Okay, then they keep the square root of 3, and then let's do half of 36 is 18, and 18 times 3 would be 54. So now I have the area of that base, that was very complicated, is 54 square root of 3. So now this part, next part should be easy. Since the area of the base is 54 square root of 3, now they're going to find the volume of the pyramid. Volume is equal to 1/3 area of the base times the height of the object. 1/3 stays. Area of the base we just found, and the height of the object is 8. And when you multiply that out, you get that as an answer. If you put in your calculator, you get that. So a complicated problem, you might have to play this back a couple of times just on this example here to understand that whole mess in the corner here, which comes from our last chapter with 30, 60, 90 degree triangles. Okay, that's the end of this lesson. Good luck.